Hi, and welcome to this talk on the validity and reliability of the Internet Users Information Privacy Concern Scale, IUIPC. My name is Thomas Gross. I'm from Newcastle University in the United Kingdom. Let us first consider the impact of measuring privacy concern. Instruments measuring privacy concern are an important ingredient in investigating antecedents of privacy behavior. They are also crucial for investigating the privacy paradox, that is, the attitude-behavior dichotomy we find in privacy research. In developing the Internet Users Information Privacy Concern Scale, IUIPC, Malhotra et al. Considered information privacy concern as an individual's subjective views of fairness within the context of information privacy. IUIPC 10 is one of the most used privacy concern scales. It has a reputation to be diligently created in an evolutionary fashion, and it has a sound theoretical underpinning in its content validity. In this table, I'm giving a brief overview of Internet Users Information Privacy Concerns, IUIPC 10. It's a 7-point Likert scale anchored on strongly disagree to strongly agree. You can stop the video and read the scale at your leisure. Now, what is the aim of this research? In this talk, I'm focusing on the construct validity and reliability of IUIPC. And this considers multiple aspects. First, we're looking at factorial validity and unidimensionality of subscales. Second, we are investigating convergent and discriminant validity. And third, we are considering internal consistency as a reliability notion. Now, the paper also concludes an investigation of content validity, that is, relevance and representativeness of the content in the questionnaire, and an estimator appraisal, which is which estimators in confirmatory factor analysis are best suited to use with IUIPC. Let's have a look at how we investigate construct validity and reliability. First of all, validity means whether an instrument measures what it purports to measure. For construct validity, we first of all have factorial validity, which means the factor composition and dimensionality are sound. So that means we're testing goodness of fit hypotheses and metrics. Secondly, we're looking at convergent and discriminant validity, which means items belonging to the same factor are meant to relate to each other, and items that do not are meant not to relate to each other. Finally, we have a number of criteria that we use to evaluate whether we have a sound construct validity or not. And that is that the standardized factor loadings beta are greater than 70, that the variance extracted is greater than 50%, and that the heterotrait monotrait ratio HDMT is less than 0.85. Now, we are considering as reliability the extent to which a variable is consistent with what is being measured. And that could also be considered as a capacity to separate signal from noise. Reliability for us means especially internal consistency, and one of the tools we're using for that is congeneric reliability omega, the amount of general factor saturation. We are also considering the average variance extracted, AVE, which is the average of the squared standardized loadings belonging to a factor. Now, for those, we are expecting that congeneric reliability omega is greater than or equal 0.70, and that the average variance extracted is greater than 50%. We are first considering the common factor model and the foundations of confirmatory factor analysis we use in this research. I'm using a metaphor here that was created by Sasha Eskamp. Imagine we are attempting to measure the unobserved latent variable solar irradiation. We do this by creating indicator variables which reflect the impact of that latent variable, and here those are thermometers. We might not just have one of those, but multiple indicators reflecting the latent variable. These indicators are also impacted by error variance that we are putting into the model as well. Now, as analogy for privacy concern, the latent variable would be privacy concern, or one of its subscales, and the indicator variables are the items in the questionnaire. Now it's all about measuring variance and covariance between different indicators, and what we seek to find is a common variance that is attributed to the latent factor. In addition to that, we have unique variance, which is composed of the specific variance of the indicator and the area variance. Let's take a look at the procedure of this study. So first of all, we had a data preparation phase, looking at completeness, attention check, distribution, outliers, and so on. We then conducted a primary confirmatory factor analysis on our base sample, which allowed us to investigate whether we have validity and reliability for IUIPC in the first place. Then we had a phase of diagnosis in which we investigated the factor structure further, in which we looked at the reliability and a possible respecification. And this we considered with the base sample as well as with an auxiliary sample A. Finally, we had a validation phase in which we checked our findings on an independent sample to make sure that our findings are actually holding up. Now, I've been stressing that we had 3 different samples for that, and I'm going a bit more into that. So first we had a base sample, which was our main sample for the confirmatory factor analysis. So that is the sample which was at the foundations of our research. Now, to make decisions about possible problems, about diagnosis of what is going on, and get an independent information source, we had an auxiliary sample that helped us to make these decisions. Finally, we had a validation sample that we didn't touch until we decided how we would respecify the models or IUIPC, and then used that to check that our findings are actually holding up. Here I'm giving a brief overview of the 3 samples. We have the samples base and validation on the right hand side over here. They were acquired with prolific and meant to be representative of the UK population in terms of age distribution and gender distribution. Sample A, the auxiliary sample here, was not meant to be representative. Let's have a brief look at distribution across samples. Naturally, IUIPC yields ordinal variables with 7 levels. It comes at no surprise that those distributions are non-normal, that they are substantially negatively skewed, and that they are partially leptokurtic. Now, these observations have consequences in what estimators one would use for confirmatory factor analysis, and you find more on that in the paper. When it comes to construct validity, we're looking at factorial validity under an MLM robust estimation as a baseline for the different models. I'm giving you the factor loadings over here as a context for that. Now, what we found was that the goodness of fit with the chi-squared was statistically significant. That is not supporting the model. The comparative fit index, CFI, was 0.92, also not in favor of the model. And then the metrics root mean squared estimate of approximation, Ramsey, was at 0.10, and the standardized root mean squared residuals were at 0.10 as well. Both of those metrics are indicating a poor fit. Now, what we see from that is that we have a poor global fit, and that none of statistical hypotheses we used to evaluate that yielded support for the model. In addition to that, we had a poor local fit, which we found in the correlation residuals and in the statistically significant standardized covariances. So overall, there's indication of considerable misloading. So while we could find evidence to support the 3-dimensionality of IUIPC, at the same time, the subscales, the unit dimensionality of the subscales was disconfirmed. Now, this plays into the evaluation of convergent as discriminant validity, where we're looking at the standardized loadings. So we're starting with convergent validity, and here we find that for the factor collection, things are looking good. However, for the factor awareness, we have awareness 3 with a low standardized loading, and for the factor control, we have control 3 with a low standardized loading. So our criteria for those, namely that we have a requirement of a beta greater than 0.70, are not fulfilled. Now, this has direct implications in the sense of that these indicators only exhibited less or equal than 20% of the common factor variance, which is problematic for our convergent validity. And finally, for both of those factors, control and awareness, we found that the average variance extracted was less than 50% as well, which means that you have less variance extracted than uniqueness, than error variance present. As a consequence, we needed to put the convergent validity of the scale in question. Now, these results remain similar for the base sample as well as for the validation sample, so that's something that's holding up. For the discriminant validity, we looked at correlations, and there we find that we have considerable correlation between indicators across factors. So where we would normally expect, as we have in collection over here, that the indicators have a strong correlation within the factor boundaries and little correlation to other indicators, we don't quite see this as strongly in control and awareness. And for that reason, the Fornell-Lacker criterion was fulfilled on the main sample but not in the validation, and the HTMT criterion was fulfilled. Now, what we find here is that the discriminant validity is borderline acceptable, and given that the validation sample showed a failed test on that, it's always something I would want to check. Now, when it comes to reliability, I'm drawing attention to the signal-to-noise ratio as one way of looking at that. Now, what we have found is that the congeneric reliability omega was below the threshold of 0.70 for control and awareness, which would indicate a failed reliability criterion in itself. Now, this also implies that we have a low signal-to-noise ratio for these two factors, and that causes some problems. Now, what you see in this graph over here is the signal-to-noise ratio for the different factors, and what I'm pointing at on the left-hand side here is the signal-to-noise ratio for the factor collection, which is actually doing quite well. However, for the factors control and awareness, the signal-to-noise ratio drops considerably, and that can cause problems. The consequences are as follows. There is a considerable amount of specific and error variance that may mask the two privacy concern scores you investigate with IUICP. Now, the low reliability implies that there is an attenuation of the impact of privacy concern on other variables. So this means that the magnitude of the measured effects of privacy concerns on other variables, such as behavior for instance, will be reduced. And this in turn is undermining our investigation of the privacy paradox. And that is one of the main concerns I want to convey with this talk. We attempted to alleviate that situation by respecifying IUIPC. We created a compact version of IUIPC we call IUIPC 8, in which we eliminated indicators with minimally acceptable loading, such as control 3 and awareness 3. Now, this clearly comes with a trade-off. You gain a better fit, better conversion and discriminant validity, as well as internal consistency. we can show that the fit is statistically significantly better with the Wong nested likelihood ratio test. On the other hand, we lose information. We're having 2 fewer items in there, and we have a risk of non-identification because of 2 indicator factors. Now, if you're comparing the IUIPC 10 version, the original, and IUIPC 8, we see the following. You have IUIPC 10 over here with both samples B and V, and IUIPC 8 below, again with 2 samples. Now for the factorial validity, both samples failed to show that the model is sound for IUIPC 10, and we have problems with convergent validity as well as a bit of a toss-up for discriminant validity. Again, reliability, internal consistency is failed here. Now for IUIPC 8, the situation looks slightly differently. So on the one hand, we have a better situation in terms of the fit, not perfect for the base sample, still getting much better metrics on this. We have a good convergent and discriminant validity as well as a sound internal consistency. So in that sense, IUIPC 8 gives you better metrics to work with. When I first investigated IUIPC, I found that it had a lot going for it. Especially, it has strengthened its underpinning in content validity, that is, in relevance and representativeness of its content for the question at hand. Also, the proposed 3-dimensionality of the scale seems to be adequate. Still, we couldn't confirm IUIPC 10, mostly based on the problems in construct validity. And that finds expression in unsatisfactory global and local fit, in the questionable unidimensionality of the subscales awareness and control, and the problems in convergent validity. Now, it's especially important to consider the impact of low reliability on the attenuation of relations to other factors. That means that the measured effect size between privacy concern and other factors such as behavior will be diminished. Hence, if we are investigating the privacy paradox, the attitude-behavior dichotomy, we might not see effects that are actually there because of this attenuation. That means if we really want to investigate the privacy paradox properly, we need to have valid and reliable privacy concern scales instruments to investigate this. Finally, we've proposed an alternative to IUIPC 10, a compact version called IUIPC 8. It gives you increased validity and reliability at the price of a trade-off towards reduced information and less redundancy in the scale.